Hello guys, in this video we will create the interaction system. It will be very expandable and universal. Basically, we will have the one base class with the interaction widget, and when interacting our object, the widget will give us a feedback, and all the children that inherit from the base class will have their own logic. So, as for the example, I'll create different kind of objects with their own feedback to our interaction. I hope you like this video. So, let's get started. We will begin with the easiest part. It's actually the material for our widget. The most common layouts for interaction widgets are actually radial progress bars. For this, let's go inside our GUI folder, and on the level with HUD and icons, let's create a folder and rename it to materials. So this type of materials are dedicated only to the graphical user interface, so we will store them here. Now go inside the materials folder, press right mouse button and select material. Let's go with the name of m_radial progress bar. This will be our master material. Now select it, then press right mouse button and select create material instance. Rename it to MI, which goes for material instance, Radial Progress Bar. Material instances are used for quick customization of the parameters which are exposed from the master material. The first step in developing our radial progress bar is to create a radial gradient. Next, to make logic which will calculate the value between the vectors, so we can have the percentage of progress bar being filled. And the last step is to apply a mask, so we can actually transform this value to the layouts of actually a progress bar. So let's open our material and begin developing. To create radial gradient, we need to add texture coordinate node. You can search for it at the context menu, or actually go with the shortcut, it's U plus left mouse button. If you expand this node, you can see that we have two vector dimensions, U and V channel, U for the red one and V for the green one. The start of, or the begin of texture coordinate is located on the top left corner. It's 0, 0, and the movement on the U channel goes from the left to right in this direction, so 0, 1, and for the V channel from top to bottom, 0, 1. So left top corner 0, 0 coordinates, right bottom corner 1 and 1. For the radial gradient, we need to have pivot point in the center of our texture coordinate. So basically, we need our left top corner move to the position of 0.5, 0.5. For this, we need to search for subtract node and actually you can go with setting the value right in this node, but I don't like this method because if you have very complex shader, it's quite difficult to search what you actually are doing in the whole logic. So I always use constant parameters so I actually see what I'm doing with my logic. Now you can select the subtract node and select start preview node. So in the preview window you can actually see the result. As you can see, right now our pivot point is in the correct position. Now let's move on. Also keep in mind that when you subtracting the vector 1 attribute from the texture coordinate, it will actually subtract this value both from U and V channel. We can actually do the same, but with the vector of 2. As you can see, we have the same result. But this type of logic is more flexible. For instance, we can move on our texture coordinate independently on each axis, just like this. So you can experiment, and I'd like to recommend to read the official documentary on how math expressions work with Material Editor. Now let's search for custom rotator. It's a material function which allows us to rotate our UV coordinates using our pivot point. So connect the result of the subtract next. As you can see, the default value for the rotation center is vector 2 of 0.5, 0.5. We actually have the center right here at the proper value, so for the rotation center we can actually go with the constant of 0. For quick adding nodes, for instance, vector 1 is 1 plus left mouse button, vector 2, 2 plus left mouse button, vector 3, 3 plus left mouse button, and so on. Now, the rotation angle is the value that, as we can read from the description, returns the value of 360 degrees turn. So If we have the value of 0, it means we have 0 degrees. If we have the value of 1, we have 360 degrees. So basically the value of 0.5 is 180 degrees and 0.25 is 90 degrees. All progress bars actually start their filling logic from the position of 90 degree. In other words, it's like 12 o'clock if you look at the watch. So let's see how it actually would work. Right now we have 0 for our rotation angle. We actually need to adjust the rotation angle. For this, let's add another constant, but with the value of 0.25. And look carefully at how the UV coordinates will change. Well, you see, the colors switched their positions. So basically, if we go with the value, for instance, 0.375, you can see that our UV coordinates are actually rotating. Now, let's move on. Now, let's search for the node that is very useful in our case, which is called vector to radial value. This node, or actually material function, gets our UV or vector input and outputs the value converted to an angle. As you can see, now we have another way of representing our UV coordinates, and we are actually interested in the output field called vector converted to angle. Now it outputs with two dimensions, u and v, but we actually need the gradient colored with black and white. So pull a wire from the field we need and search for component mask. Here disable the green channel and preview our mask. As you can see, now we have the gradient from white to black. Now let's search for the if condition. The shortcut for this node is I plus left mouse button. And let's make the logic for computing the percent of how much progress bar should be filled. For this, connect everything as you can see it from the video, and I'll explain it right in a minute. We actually need one more attribute, but let's change it to a parameter, not a constant, and call it fill bar. Now, the logic behind this is pretty much simple. We are measuring two values from the UV, or actually linear gradient, and the value which is gonna be our fill bar. So when they are equal, or our A input is higher than the B input, it means we are covering the most parts of our UV coordinate. So we go with black color. It's 0. When we need to cover or fill our bar with, for instance, quarter, we actually see that the quarter of our UV coordinates is colored with the white color. Basically, if we change this value to 0.75, it means that 3 parts of the 4 parts of our UV coordinates are actually covered with the white color and 1/4 with the black one. I hope you understand the idea. And the last, what we need to do is to create the radial mask, which we will apply to our logic here, so to achieve actual radial progress bar. Now, for creating the radial gradient, we actually can use the function called radial gradient exponential. If we preview it, we can see that we have not hole but the opaque or fill from the inside circle. But for the progress bar we need actually a contour. So the inside parts of our circle should not exist. You can actually use this material function. It's not so heavy, but I'll show you how to get the actual result with the use of some nodes. We need UV coordinates, then the node called distance. Here we need to provide the vector 2 with the values of 0.5 on both. Next, let's multiply the result to the value of 3. Actually, the multiplier here will lead the higher the value in the multiply node, the lower size of our circle we will have. Now 1 minus, and as you can see we have a pretty neat circle. And as I said earlier, for instance, if we change the multiplier to 9, the circle will be smaller. Well, what I like most in material functions that came from the engine, you can actually, and you can do it with any material function, you can just double click on it and see the logic which they use to achieve the proper result. So let's go back to the topic of our tutorial. Well, let's continue. Let's add 2 radial gradient material functions. And the logic is pretty simple. This is the bigger circle we have, this one the smaller. We will subtract from the bigger one the smaller one to get the contour. As you can see, each attribute has its own default values, and in this way we are actually good with them. The radius of 0.5 is the highest value to visualize the circle. For instance, if we go with the value 0.6, we are actually out of the bounds of our UV coordinate. So keep it in mind. Let's create an attribute for the smaller circle. And let's go with the value of 0.4. Now search for subtract node. Let's take a look at what we have at the moment. You can see that the density or sharpness of our mask is very low, because we have only 2.33 in both of our nodes. To make our contour more sharper, let's, for instance, go with the value of 25 in both of nodes. Now, as you can see, this one looks more proper, and subtracting the higher value leads to the thinner contour, like this. And for instance, with the value of 0.1, we'll have this kind of result. Let's continue. Now, for the radius of smaller circle, let's actually change it to parameter and call, I guess, bar width, or actually thickness. And let's set the default value to 0.30 or 45. Now we are actually pretty much at the end of developing our material. Let's take a look at what do we have at the moment. So the way the material editor works can be described like the layers or the masks in Photoshop. The subtracting, adding, multiplying functions are pretty much similar to the result that we can achieve in Photoshop by doing the same actions. So let's search for multiply. The shortcut for this is M plus left mouse button. And let's see the result we have right now. As you can see, the fill bar has the value of 0.75. It means 75%. So our bar is filled on 3 of the 4 quarters. 3 of the 4 parts. And for instance, changing it to 0.25 means only a quarter. Just like this. But we don't need to have only these parts visible to make our material look more attractive. Let's actually add some minor changes. I'd like to add dark version of the contour, so it will be the background for the whole widget. For this, I'll add another multiply node, then a constant attribute with the value of 0.25. Next, I will connect everything, and actually I need one more node, which is called add, so I will add the result of this operation with this operation. Actually, it's like combining two masks together. For the add node, you can go with a shortcut with A plus left mouse button. Well, let's select the main nodes of our material and add some changes. Let's change the material domain to user interface, so our material will be applied only for the UMG widgets. And for the blend mode, let's go with masked or translucent. I prefer translucent over the mask because the results are much more smoother, because we have some subpixels. And we need the color, so our material will be visible. For this, press 3 and left mouse button to create vector 3 node, then right click and select convert to parameter, call it color, set the value, or actually set the color you like. I'll go with simple white, then connect the pins and let's see how it will look. Actually, we have pretty decent result. Press apply and save. Our Radial Progress Bar is done, and let's go back to the content browser and open the material instance of our master material. Here I'll demonstrate you how the progress bar actually works. For this, I'll check all attributes. I'll go with the color, so maybe this one. As you can see, the color is applied to both masks together. We can make the separate variation. Actually, I think I will do it, but for the demonstration, let's just go with this one. Let's change the thickness of our progress bar like this, and Now we have no progress field. Let's change it a little bit, and as you can see, everything works fine. So let's create separate. Let's make different colors to apply for their own masks, and for this tutorial this will be enough. I think I'll make interaction system in two parts: the easy one with this radial progress bar, and the more heavy, if I can say this, as the second part. Well, guys, to save your time, I have prepared the full material and I'll explain everything, how it works, because that's actually my second try. I've made 10 minutes of video capturing, but when you are developing something in material editor, actually my laptop couldn't handle it. Only audio was playing in a proper way, but the video was laggish. I've actually updated to newer version of OSB Studio, and tomorrow I will try it to see whether there will be lags while I am recording this video. But nevertheless, let's begin. As you can see, I have rearranged the nodes so they look a little bit prettier than they were before. So the main problem with combining the masks is, for instance, if we take a look at the basic mask, which was our background, as you can see, it captures all the UV space. If we look at the mask that was for our percentage, it actually captures only part of it. And when we combine background mask with our percentage mask, they actually, in this particular place, overlays. And for instance, if we have background color red and the percentage mask color blue, so overlaying artifact in this part of UV coordinates will be actually violet color. So to prevent this, we need to subtract from our background mask this part. So I did it right here, and as you can see, we have the rest of our background. Then combining these parts together actually leads to the full circle. Each mask works independently, so we can apply a color to each of them. Let me show you. As you can see, the white one and the gray one. I'll go with a red one for the background, so you can see the difference more clearly. Now, as you can see here, changes 2. We are actually multiplying our color with the alpha channel. So we can control both color and the opacity of our mask. This one is applied for the percentage mask and this one for the background mask. Then combining the results actually leads to two colors that works separately and in a proper way. So for instance, we'll change fill color to blue, and background color to red. Change opacity to 1, and you can see the colors are quite solid. Now we'll change the percentage coverage, for instance the half, and everything works fine. Let's make some changes one more time to see how it works. So now I like the way it works, and that's all for this video. So please leave a comment, subscribe, and see you in the next video, where we will where we will complete developing our interaction system. Thank you.